In this tutorial, I'm going to be showcasing another way that we can combine SQL and Python for some really powerful but also lightweight data analysis. So we're actually going to be using SQLite3, the 3 referring to its use case with Python 3. And it's interesting if you're used to traditional RDBMSs because it's more of a gentle introduction to combining Python with databases. So it's actually a file-based database, and this will make more sense as we go into the code demonstration. There's no installation required, which is really nice, just a simple, it comes packaged within your Python installation, so it's just a simple import as a dependency. It's lightweight, which means it's really good storage if you don't need a dedicated server or cloud storage, if you're developing apps, you're doing some game development, or alternatively, data work. It's a nice gateway into working with APIs and connection strings, which can be quite troublesome and quite hard to get your head around. So this is a nice, gentle introduction to that. And it's really good for building. You could build out multiple tables, get a feel for database modeling, how you can connect different tables with SQL, and also sort of maintaining data integrity and accuracy. So in the next section, I'll just go over a quick preview of what this will look like, what we'll be doing, and then we'll go into the more long form sort of build out of the code. So what we're going to do here is essentially we've got really a few functions and some SQL queries, and we're going to combine these and just call the functions at the end of the script to keep everything really tidy. We could create, just do this free form, maybe even connect lots of different files to a main.py file. But this function-based approach is going to keep our code really tidy, allow reusability, and just make everything sort of done as per best standards. And as you can see here, we'll be able to enter data that we've defined and then showcase it by just selecting the data. Then you could go ahead and use all the SQL queries or, ANSI standard SQL querying that you'd like to incorporate. So the first thing that we need to do here is actually go ahead and import dependencies. The only things that we need currently is SQLite3, again, the 3 referring to Python 3. And from SQLite3, we're going to import error, which is actually going to enable us to wrap our code or some of our functions within try except blocks to get more detailed error messages, which may be helpful if there are syntax errors or SQL specific errors that are prohibiting us from connecting to, inserting, and querying our database. So essentially what I'll do throughout is show the individual functions that will use the SQL query strings, and also we'll call these at the bottom of the script just to keep everything quite modular and clean. So in the first function, I just define it as a custom name, create connection. And within here, we wrap it within try except blocks because that will then execute an error within the except block of the code. And what will happen, it will print an error message using the import error that we've taken from the SQLite3 package. Now, throughout here, what we're doing is essentially we're creating a connection variable that is equal to the connect method within SQLite3, which will simply connect to our database. So that's the core elements. And then within here, we can define connection equal to the create connection method, and then we're just specifying the path. Now, we don't have a file explicitly set or a file that already exists within our folder that I'm connected to, just a local SQLite3 folder. So when we run this, it's actually going to create our inventory file. So like I said, this is file-based SQLite3. It's lightweight. We don't have to depend on anything in the cloud. And when I go ahead and run this, this will, first of all, go through our function because we've called it with the arguments set by the parameter, which is simply that path. And when we run it now, what will happen is it will go ahead and tell us if the connection was successful. We get database connection successful. And also we see that inventory.db file, which is essentially our database here, will also be created within our folder structure locally. So that's the first piece of the puzzle. And this connection will also be used in our functions going ahead because we'll need to reference our connection when we also specify the query. So next up, what we need to do is create a table schema. So I've just called this again a function to keep everything clean and reusable. I've just called it adding data. And the parameters here, we need a connection, which we've already defined so that we can connect to the database, and a query, which you can see laid out below called table structure. Now we have a cursor method here, and what this does is this actually is just our way to basically write the queries to the database. So in our try block, we try to execute our query, and then commit is important here because this can't actually be sort of materialized within the database without that commit method there. And then we can print within the try query successful. And then again, we have our except block where if it doesn't run, we've got that error message that we've taken from SQLite3 that will print to the terminal or whichever output you choose. And I'm just writing some pretty standard SQL here. I'm going to create a table, but if not exists so that we don't overwrite or recreate anything. And I'm just going to call it locations. And I'm going to give it 3 columns. First of all, the location ID, which we won't actually have to input because I've set it as primary key auto increment, which means without our input, any record that is assigned, it will just automatically become record 1, 2, 3, 4, 5, and so on. Name text field, and we don't want it to be nullable, so we always want data there. That's an important constraint. And is active, so there's not actually a Boolean or a bit data type within SQLite3, but I've went around this by creating an integer, and also with the check constraint, I just want that to be either 0 for false or 1 for active. So again, we can call our function, uh, and we've got adding data here because that's our function name. We've specified the connection string above in the function calls in the line above, and table structure is the query we want to run. As you can see in the adding data function there, we take 2 parameters, connection and query, and we call those arguments. So now we can see, as per our function, we get query successful. So that's worked, and we now have a working table structure that we will need to input data in. So that will be our next step. So you can see the benefit of the functions here. They're starting to be quite reusable and clean, even if they look a bit hard to get your head around at first. They're still very beginner friendly. And now to actually insert our data, and this is where the repeatability of the function comes in, I can just write another query and we can use essentially the adding data function above, because the reason that we specified a new function is because we need that commit method. So we can just simply insert the values into the data by using the adding data function, and we just need to change the name of the query. So we can just duplicate that and then change the name of the query to input locations data as you see it defined above. And we only have to insert the location name and is active. Like I said, the ID is auto incremental, so it will do it for us. And we will see we commented out the line above, so we should only have one message for query successful. So that's worked. So now we need to get to the final stage where we actually go ahead and query the data to check that it's in the database and it looks right as per the way that we've set things up. So as we can see, we've put in the name, London, Tokyo, or Paris location name is active, a 1 or 0, essentially what is a Boolean or bit value, which will basically say if that location is currently, if we were to connect this up in a model, we could connect it to our stock and we would see if it's currently holding stock and so on. So now we need to create one more function to query the database to display data ultimately. So we'll just call this run query. Again, we specified the connection and we just need a query. And here we go, we have the cursor again, a try block, which simply executes off that method. And then we're going to essentially get a result which will be equal to fetch all, which is just the way that we can display the results of our SQL query. And then standard, we have our error block displaying an error message if it doesn't work. And we just have a simple query, select all from our locations table, essentially. So I'll comment out that line. And we can see here to call this, we've got the locations data that we've set equal to run query, that final function, with the connection and the locations data, our query that we've specified just to show all of our table data. And here, because we're calling it through the cursor, we just need to write a simple for loop to iteratively display every row within our database. So we essentially take for location in locations data every single line, and we print out the result of that. So now we can go ahead and run the query, and you can see we get all our results. So we'll get an ID of 1 for London, auto-incrementing to 2 for Tokyo and 3 for Paris. We didn't have to do anything there. And we've got the name, London, Tokyo, and Paris, and whether that is active or not with the 1 or 0 flags. So that's successful, and everything's worked as we'd like it to. So we can go through the file again and just break down what we've done. We've imported the dependencies. We've created a function to sort of create a connection to the database. And through that, we've specified our own database file when we've called it. And then we have a function to go ahead and create a table structure, but we can use this again simply to add data almost through a query, just to insert data to our table structure. And then we just specify our queries. We can do that in a modular way with the function. We get to reuse that adding data function again, and we'll just have the input data query as well, basically whatever we want to input to our table. And then we just need to remember to use that fetch all when we're running our query to display our results, and then we return it within a for loop just to show every line. I've commented out those adding data fields just while we run the query, just so that we're getting just the necessary outputs. And again, if we were to run this again, we would see we've got a new line. We're not overwriting our data because we've commented those lines again. We get the values that we've inputted. You can go ahead and modify this. You could update data with a where clause. You could group data, do whatever you want traditionally with ANSI SQL. And this is really good for getting to grips with APIs, with connection strings, functions, clean code, and also sort of looking at a more alternative, lightweight database, because you may not require a large server or cloud-based database approach.